All right, let's talk about the invisible forces that are quite literally holding our world together. We're diving into engineering mechanics. Now, this sounds complicated, but really, it's just the rule book that explains everything, from why a massive skyscraper stays standing to how a simple game of tug-of-war actually works. It's the physics behind almost everything we build, and we're going to break it all down.
So here's our game plan. We're going to start with the big picture, what engineering even is. Then we'll zoom right into the heart of it all, force. We'll look at what happens when multiple forces get involved, and then the grand finale. We're going to uncover the secret that keeps enormous structures in perfect, unshakable balance.
Okay, first things first. To really get what mechanics is all about, you have to understand the partnership between science and engineering. You know, they're like two sides of the same incredible coin.
And this quote right here, this nails it. Just think about it for a second. The universe has a set of rules that you just can't break. Science is our mission to figure out what those rules are. But engineering is where we get clever and use those rules to our advantage.
And you can see the difference so clearly here. Science is all about knowing. It's about figuring out why that apple falls from the tree. Engineering is all about doing. It's about using that knowledge of gravity to design a plane that doesn't fall from the sky. One is pure discovery, the other is all about application.
And this is just a beautiful example of how it works. So, science figures out, hey, you can't really squeeze water into a smaller space, it's incompressible. An engineer hears that and goes, wait a minute, if I push on the water over here, that force has to pop out somewhere else. And boom! Just like that, you get the hydraulic brake, where your foot's tiny push on a pedal can generate enough force to stop a 2-ton SUV. It's brilliant.
Okay, so now that we've got that relationship down, let's zoom in on the main event for today, the world of mechanics itself.
Seriously, if you only remember one thing from this whole explainer, let it be this. At its absolute core, mechanics is just the study of two things: forces and what they do to stuff. That's it. It's all about the pushes and pulls and the consequences they have on objects. Now, to make life a little easier, especially when we're starting out, we make a really important assumption. We focus on what we call rigid bodies. Basically, we pretend that the objects we're studying don't bend or stretch or deform at all when you push on them. Now, of course, in the real world, everything gives a little, but this idea is the essential starting point for almost every calculation.
And right away, we can split this whole field into two big camps. On one side, you've got statics. This is all about things that don't move. We're talking bridges, buildings, that chair you're sitting on. The whole goal in statics is to achieve perfect, stable balance. Then, on the other side, you have dynamics, and that, as you can probably guess, is all about things that are moving. Cars, airplanes, planets, you name it.
Okay, so, it would be really nice if only one force ever acted on an object at a time. But the real world is messy. Usually you've got a whole bunch of forces all pushing and pulling at once. And when you have that, you've got what we call a force system.
So if you've got this whole jumble of forces, gravity pulling down, wind pushing from the side, the ground pushing up, how do you even begin to make sense of it all? Well, the first step is to get organized. You have to classify them.
And we pretty much sort them by their geometry. So are all the forces happening on one flat surface, kind of like laundry hanging on a clothesline? That's coplanar. Or maybe all the forces, if you trace their lines, would meet at one single point. That's concurrent. Or maybe they all just run parallel to each other. Figuring out which group they belong to tells us exactly how to solve the puzzle. So you have all these forces coming from all these different directions. How in the world do you predict what's actually going to happen? Well, you don't. You don't analyze every single one. Instead, you find the one single force that represents the combined effect of all of them. And that amazing all-in-one force has a name. It's called the resultant. Think of it as the net result, the final score. It's the one single arrow that tells you, after all is said and done, which way the object is really being pushed or pulled. Finding this is absolutely key. And for two forces, there's this really cool and elegant visual trick to find it. You just draw your two forces like they're two sides of a parallelogram. Then you complete the shape. And see that diagonal that cuts right through the middle? That's it. That's your resultant force. It's so cool because it turns a complicated physics problem into a super simple geometry puzzle.
All right, this is where it all comes together. We're at the finale. Let's connect all these ideas, force systems, resultants, and figure out the secret that keeps our whole built world from just crumbling down.
I mean, really, stop and think about it for a second. A huge bridge has its own massive weight pushing down. It has hundreds of cars pushing down. It has wind pushing sideways. Why doesn't it go anywhere? The answer is that there's a perfect counterattack to that resultant force we just talked about. And here it is. This is the hero of the story. It's called the equilibrant. So if the resultant is the sum of everything trying to move the object, the equilibrant is the one single force that pushes back with the exact same strength in the exact opposite direction. It's the great neutralizer.
And this all comes down to one single beautiful number, 0. For that bridge to stand, the resultant of all the forces trying to knock it down has to be met with a perfectly equal and opposite equilibriant force pushing up from its foundations. When they cancel each other out, the net force is 0. And that, my friends, is the very definition of being stable.
And that's really the heart of it all, isn't it? Engineering mechanics isn't just about building stuff. It's about being the master of an invisible, perfect balance. It's a constant, silent battle against forces, and a battle we win by understanding them. So the next time you see some massive building or bridge just standing there perfectly still, take a second to appreciate the incredible war of forces being fought and won in that very moment. Thanks for tuning in.